In this experiment, I work on transfer functions and a time response of a second-order system, and I started manually deriving the transfer function. Then I verified my solution using MATLAB by defining the numerator and the denominator applying the TF function. And after that, I generated a step response using step SYS-T to observe the system behaves over time. And based on my results, the MATLAB output matched my manual computation, and which confirmed that my derivation was correct. And I also noticed that the system response gradually decreases and stabilizes, indicating a dump behavior. And when I compared my graph from my derived equations with the MATLAB plot, both showed the same trend. So I can say that my results were consistent and accurate. And while doing the experiment, I encountered some challenges, especially in understanding how the Laplace transform and inverse Laplace transform and are connected to the actual system response. And at first, I also not found it confusing how each MATLAB command relates to the systems, and particularly the coefficients represents the equations of the system. And other challenges for me was interrupting or interpreting the step response graph, like identifying the setting time, the rise time, and the percent overshoot. So these concepts were easy to understand in theory, but applying them to the graph required more attention and practice. For my notes, for my notes to self, I realized that I need to strengthen my understanding of the relationship between the transfer functions, poles and zeros, and the system behavior. And I learned that even small changes in the equations can affect whether the system is overdamped or underdamped or critically damped. So I should also not rely too much on MATLAB. So I need to be confident in solving and analyzing the problem manually.